our next presenter is comes from the city of Vilnius. He's going to tell us about his title of his presentation is Mapping the Future. Please.
Okay, it's working now, right? Okay. Hi, my name is Dominykas. I work as a GIS analyst in a Lithuanian company called ID Vilnius. And today I'm going to give you a brief overview of how we create GIS solutions for Vilnius city. And I hope that you will be able to gather some new ideas, or you have already created similar solutions in your city. And if so, please let us know how you did it, so we can improve our products as well. So our mission as ID Vilnius is to help to create innovative, balanced city by providing various services to the municipality and the public. We've been doing so for the last 27 years, but just recently we opened a new section of the company called the data center. Its goal is to collect different types of data in one place to make it accessible and easy to use, and basically create a strong basis for the creation of GIS solutions. And talking about them, we produce the products which could be like put into these three loose categories. And today I want to highlight some of the more interesting or recent solutions, and also want to show you how we combine different types of data and technologies to solve a variety of problems and issues in a city. So I want to begin with a few examples of how we use data collected by drones to inspect and monitor certain objects in the city. So here's the first solution. So in Vilnius city, we take images of 208 problematic waste container sites by using drones. So our drone operators take regular flights twice a day to take images of these sites. Then by using AI models, which we produce ourselves in-house, we basically use to find and identify the objects left outside of these containers. So we also see if the lids of these containers are open, also if there's a sandbox left at a container site. And once processed, all of this information travels to the dashboards, where specialists in the municipality basically see the current situation, and they can make decisions based on real data and optimize waste collection better. Another solution which uses images from drones. So while we fly those drones, we take images of the buildings and then use it to create a 3D models of them. And those models in turn are used for rooftop condition inspection. So we combine different tools to automatically identify the defects on the surface of the roof. We also right now are experimenting with using thermal imagery to see the heat loss of these buildings through the roof. So right now we have 411 3D models of these buildings. With quite a high accuracy, we can determine defects like water puddles and plant life on the rooftop, but we are still kind of in the process of developing an accurate way to calculate how much rust is there on the roof. But all in all, this type of inspection really allows us to monitor way more buildings and do it way faster than it would be possible, in field conditions. So now, keeping on the topic of like inspection and upkeep of the city, we're moving away from the drones, and this is a product which is more about public data collection. So this is a solution called Honeycomb, which is basically used to register any objects in the city which need maintenance. Broken playgrounds, unclean stairs, blocked pedestrian crossings, and so on. So how it works is that elders and their prescribed elderships use mobile apps to register these issues. Once they register them, it travels to dashboards, web application, where municipality specialists then can review these issues and assign a contractor to solve them. Also, all of the necessary paperwork and the documentation is generated automatically through templates. So these issues can be solved in one place. You don't need to send 1,000 emails or search for someone who's responsible. There's this one system to solve these daily issues in the city. And now let's move to a little bit different topic, but which is very, very important for Vilnius. It is mobility. So in order to better understand how the traffic functions in the city and understand its tendencies, we are creating an application called Vilnius City Mobility Map. So how we gather all the information about the movement of the people in the city is through the data from mobile operators. We also use other data sources like Strava app, Waze app information, but more for the data validation purposes. So once all of this data is processed, we put it in a web application where various tools lets us analyze basically the tendencies of movement of the people. We can also use provided tools to analyze historical information, compare it, see the accessibility of certain objects in the city. And all in all, this application is used by a variety of specialists who can basically see the objective real data and make decisions based on it. And keeping on the topic of like mobility and street infrastructure, another project is used for street surface condition evaluation. It's called Vilnius GSM. So how it works? Basically, our partners using LiDAR scanning scan around 2,000 kilometers of streets each year. It was done in 2022 and 2023. So once they gather this, as we call green data, from scanning with LiDAR, we then use automated algorithms to basically evaluate street condition, and it's based on different criteria, like amount of potholes in the road, unevenness of the surface, cracks in the asphalt, and so on. Also, we use additional data like population around these streets, intensity of use, and in the end, the goal is to create a list which says which streets in a Vilnius city are in worse condition and which streets need the maintenance first, and maybe which streets are a little bit better and can wait a little bit. So, as in previous examples, there's web application as well, various tools lets us analyze the street, and people in the municipality can basically plan the maintenance of these streets accordingly. And while we're talking about planning of maintenance of street infrastructure, other objects in the city, assets in the city, we noticed that there's quite a few problems spanning from such issue that there's a little bit lack of communication between utility companies, municipality, and other municipalities companies. For example, maybe there's a newly repaved street, right? And some utility company has planned to change the pipes under there beforehand. So they dug up this new street, and after they are finished with their work, we need to repave the street again, basically spending more money and creating more inconvenience for the people. So in order to solve issues like these, we are at the moment in a development stage of this project called Vilnius DEC. So at the basic level, all the municipality companies, utility company can see each other's maintenance plans, coordinate between themselves, and basically plan this maintenance more efficiently. And if we're talking about the efficient maintenance of these objects, of assets, first of all, you need probably an accurate and easy to use registry or inventory of those objects. So let's switch to the solutions which more about the inventorization of certain objects in the city. For example, we have an informational system which is used for management of traffic signs in the city. So at the core of this system is its database. It contains more than 60,000 vertical signs, 1,400 kilometers of horizontal signs. There's other objects as well, like pedestrian crossings, parking spots, guiding systems for visually impaired people, and such. And basically all of this information was gathered by using 360 images, LiDAR scanning, AI models. GIS specialists still needed to come in by hand and make some adjustments as well. But basically we have this inventory, and it's not only just a static registry. we use this system for basically any task which involves street signs. For example, if there's a new intersection being planned, this system is used to plan the signage as well. It's also used as a task management environment. So meaning the people in the municipality can create tasks for the contractors, for them to go in the field and basically do the task which is described. Moving on, we dabble in inventarization of not only above ground infrastructure, but underground infrastructure as well. So last year we finished the project which is called the Digital Twin of Vilnius City Stormwater Drainage Network. So to begin with, we needed to modernize the existing 2D data of the network. So our partners, using LiDAR scanners, scanned more than 12,000 of these stormwater wells in the city. They also surveyed around 500 kilometers of pipes. And basically, once they gathered the point cloud data, they send it to us, and we use automated algorithms to just basically create a city-sized 3D model of the network. So this model and verified 2D data is now used to basically administer and maintain the stormwater network. We can also use it for hydrological modeling, where different weather conditions can be basically simulated, and we can see if the network is able to manage these potential loads. So this project is probably the closest to what we produce, what we could call basically a real digital twin. It's based on accurate measurements. There are real-time sensors connected to it called SCADA sensors. It's used for modeling different situations. So we call it a digital twin. So we do registries and inventory of not only infrastructure, but other objects in the city as well, like cemeteries. So from previously used paper journals, we moved towards all digital space, where this registry has basically two parts. One part is public, where people can just search for the information of deceased people by name, explore data on a map. And there's a private part of the website used for administrators of those cemeteries. And using this system, they basically issue permits for burials in the city. So since 2022, through this system, more than 12,000 of these permits were issued. Also, having this registry enables us to start other projects, like monitoring of historical cemeteries. Here on the right, you can see basically a 3D photogrammetric model, which is collected while doing this monitoring of historical cemeteries. And this technology is used in other product of ours as well, which now falls into more of a public website category, which is System of Vilnius Cultural Heritage Buildings. So basically, it is a totally public website where people can explore information about cultural heritage buildings. It's in the last stages of development. Here you can see, in this website, you can see just basic information where it is, this building, to find out its attribute information and so on, but we also collect, as we shown before, these photogrammetric models of the buildings. And not only that, this system is really interesting because we also collect 3D models of these buildings' valuable components. For example, if windows, doors, balconies, even such a small object as door handles are considered important, we also scan these objects in 3D. So this website is really interesting to explore, find out new information, but it's also, the goal of it is to kind of use it as, we could like preserve these buildings in a digital space. So if anything unfortunate happens, we can restore them to the original condition based on information gathered here. Well, moving on, another public portal, which is about like historical geographic information, is called Vilnius DNA. So it is an inventory of sculptures, commemorative plaques, street art. Also, there's a catalog of really interesting information like historical maps. Some of them were digitized, vectorized basically. Also, there's a catalog of historical events, personalities, photographs, and so on. All of this information is interconnected between itself, so it's really fun and interesting to browse through and basically find out new information about Vilnius. We think of it of like a geographic Wikipedia, which is only for Vilnius city. And moving to the last few products is another portal. A lot of people talked about 3D. We have a 3D Vilnius portal as well. It's a totally public website. Anybody can visit it. If you're interested, it's 3d.vilnius.lt, and you can see all the information we have. But basically, there's a lot of information. 3D models of the buildings with not only like current buildings, but buildings which are being planned or constructed right now. There's 3D models of detailed plans, technical projects, BIM models, such things as 3D sun energy potential map, and much more. Data is constantly updated, providing almost real-time information when it comes to 3D models. And also, we're creating similar solutions for 2 Ukrainian cities of Bucha and Berodyanka to basically help them rebuild as fast as possible. And now, finally, the last product is called Lungs of the City. It's also a completely public product, which is used for examining the quality of air in Vilnius. Basically, anybody can come to this website and find out information based on different criteria gathered from 26 real-time sensors in the Vilnius city. If there's, for example, any abnormal amount of solid particles or plant pollen in the air, there's health recommendations for the public. So the municipality and the residents can find out the information about the air quality and basically act accordingly. So yeah, you just saw a lot of products we produce in Vilnius city. It's not all of them, but those which we wanted to highlight and show you. And using GIS and combining with other technologies, we're able to basically tackle all sorts of problems. But in the end of the day, our goal is to basically improve the quality of life of the Vilnius residents, at least in one small way. And basically, as you probably can understand, while creating these solutions, there are a lot of challenges, and many of them we managed to overcome, but there's still some aspects which need improvement. So if you have any thoughts of how things could be done differently, if you created similar solutions, please contact us. And if you're interested in our expertise, contact us as well. We're happy to share the knowledge and collaborate. Thank you.
Thank you, Dominykas. It's really, really advanced work.
Thank you.
Questions from the audience?
Yes, thank you. We have one interesting question. It's about mobile data. Obviously, you somehow generalized the data, not with personal attributes. Okay.
Yeah.
And the question is, did you get or got the mobile data for free, or the mobile operators ask some fee for it?
To be honest, I'm not really sure about these aspects because I'm just a technical person, but we have some sorts of agreement with it. So with the mobile operators, it's probably went through municipality for us to get the data. So if somebody is interested in more details like that, I'm not really probably the person to answer it, but you can contact us and we can provide the answer for you guys.
Okay, thank you. And any more questions from audience? Yeah, just appeared. What do you use for photogrammetry?
I don't know, they use some sort of device to scan it around, and our colleagues probably, I don't know how they combine the data, to be honest. Once again, I'm not a 3D person, but when we, oh, please answer.
We're using 3D scanners, photo cameras and drones and combine them to create this data. For example, for smaller parts, we use like very accurate laser scanners.
Thank you. And a little bit general questions. How many employees, contributors working in Vilnius in this ID and the IT?
In ID Vilnius, as a whole, there's 147 employees, I think. But the people who work with GIS is a smaller part. They're also architects, environmental specialists, and so on. So with GIS, just, I don't know, I guess like 60, 60, something like that. With people who are GIS specialists, basically from all sorts of fields, but not only GIS, they also do like AI right now, drone operators, and so on.
Yeah, thank you very much.